In this video we have the integral of 1 over x squared plus 1 quantity squared. And even though the integrand is a rational expression, you might want to try the method of partial fractions. I don't think it works very well here. You can try it if you want. I would try a trig substitution, the way this expression in the parentheses looks here, x squared plus 1. But give it a try and I'll be right back. So I'm going to let x equal to tangent theta. So taking the derivative here, differential, we have dx equals to the derivative of tangent is secant, so this will give us a secant squared theta d theta. So we're going to transform this integrand into an expression involving theta. So for my dx in the numerator, that'll be replaced by secant squared theta d theta. Now I need a replacement for this right here. So that would be x squared, and x is tangent theta, so that would be then tangent squared theta plus 1. And this, of course, using one of your basic identities, is the same thing as secant squared theta. And then this is to the second power, so this then will be squared. That's your x squared plus 1. This will be squared, and of course this one will be squared. So we'll get over here then, dx is replaced by secant squared theta d theta. And in the denominator, the x squared plus 1 quantity squared replaced by secant squared theta squared, so that'll be secant to the 4th. And of course this secant squared and secant to the 4th, we can reduce that down. I'll divide this out, 2 of these, so we get 1 over secant squared theta. And this can be written as secant and cosine are reciprocal, so I can write this as cosine squared theta. At this point, I have cosine to the second here. So to get that to a first power, we're going to use a half angle identity here, one that corresponds to cosine squared theta. And that's going to be 1 plus cosine 2 theta over 2. So that's your half angle identity for cosine squared. This is d theta here. Half angle, double angle, they're mixed in there. And now we can integrate this. We can write this as 1 over 2. Integrate with respect to theta. So I'll put that over here. That's going to give us theta over 2. And then for this one right here, you're going to go off cosine is sine. You have this 2 theta here, so that's going to give you an extra factor 2 in the denominator. This will be plus 1/4 sine of 2 theta. This is plus your constant of integration. Now this is going to equal 2, and I'm going to have my triangle. I'll put my triangle right over here. Right triangle, say this will be theta here. This will be x. Tangent of theta is x, or x over 1, so the 1 will go here. And then this will be the square root of 1 plus x squared. Now in order to use the triangle though, I need just plain old sine here. So let's do this. Got theta over 2. Identity for sine of 2 theta can be, or sine of 2 theta can be written as 2 sine theta cosine theta. Again, your double angle identity reduces it from 2 theta to just plain theta. And then this 2 over 4 here, give me 1/2. So this is sine theta cosine theta, plus your constant of integration. Now that's your answer in terms of theta, but we started off with a variable x here, so now we have to go back. So theta over 2, we look at the triangle over here, we know that tangent of theta is equal to x. So computing the tangent inverse of both sides, we get theta is equal to tangent inverse of x. You can use arctangent there also. So this then is going to be theta will be tangent inverse of x. Again, you could write out that also as arctangent. And this is the coefficient here, the 1/2. And then we look at the triangle again, sine of theta is x over that radical. So let me just do it here just to save some space here. Sine is opposite over hypotenuse, so this will be x over the square root 1 plus x squared. The cosine is the adjacent, which is 1 over the hypotenuse, so this will be times 1 over the square root 1 plus x squared. And these denominators will multiply, cancel the radical, will give me 1 times x over 1 plus x squared. So the next step here, then I'll have a plus, and I'll have the 1/2 here. I'll just put this in parentheses, x over 1 plus x squared, plus your constant of integration. So again, we have 1/2 tangent inverse of x, or arctangent of x, plus 1/2, and then x over 1 plus x squared. Radicals cancel each other out. This is the solution. Thanks for watching. We'll see you next time.